Hey guys, K2's Retro Workshop. Today, we're going to be messing with a prototype kit. This is a really cool prototype kit. I almost didn't pick it up in an estate sale recently, but it's got a lot of really interesting stuff for us to look at. And this is an EL Instruments Atom 5005 mainframe. Basically, this is everything you need to do basic digital prototyping, and you won't need any other accessories. So, first up, AC power. I wish the light on there worked. I think the neon's burnt out or something. I'm going to have to fix that. But we have plus minus 24 volt. This is unregulated. We have a tracking plus minus 15 volt. So if you end up pulling the plus down to say 14 volt, the minus will mirror that at 14 volts. Then we have 5 volts at 1 amp. These are both 200 milliamp. And here's our ground connection. This whole thing basically shares ground. So if you're using just logic level stuff, so for example the LEDs, the switches, stuff like that, all of it is referenced to the same common ground. So you don't have to run black wires all over the place, which is really nice. Next up is the function generator. The function generator has a couple of functions that are really cool. We go from 0.1 to 100 kilohertz, so plenty of range for an input to a digital circuit, for example. You've got your coarse adjustment, your fine vernier adjustment, and then we've got a function switch here, sine, square, and triangle wave. No big deal. DC offset here, and amplitude. Now the function and offset and amplitude outputs only apply to this output here. The third one down, these are logic level. So these are controlled by these controls over here, but they only do 0 and 5 volts. And the top one is active high, bottom one is active low. So you have that. So the next section is the readout section. The readout section is pretty cool. We have 4 LEDs and we have a multimeter. The 4 LEDs are driven by actual circuitry, so they're buffered. So we don't have to worry about dragging down our digital outputs by driving LEDs because these take basically no current to run. They're on above 2.5 volts and they're off under half a volt. So that's really nice. The multimeter has a floating input, so you can measure anywhere in the circuit, plus, minus, whatever you want to do, no big deal. It's got voltage and current up to 300 milliamps. Voltage is good up to 30 volts, so there's a lot. Basically, you can hook this up as a voltmeter to anything on here and measure it just fine. And that's really useful for analog stuff. I'm not going to do a analog input because of these guys right now. But, yeah. Next section here is our signal source. We have 4 logic switches, 2 pulse switches. They're just momentary buttons to 5 volt logic high, but 2 10K potentiometers, neither of which are going to be useful for anything I'm breadboarding until I open this up and hit them with deoxit. And an external input. The external input's nice because I've had plenty of projects where I had to hang a heavy B and C cable off of a breadboard. And it's nice here that you can just run a simple cable down and you're done. The signal source logic switches here are 0 and 5 volt out. So logic, pulsar's the same thing, but we have 2 options here. We have an active high and an active low option, just like we had up here on the function generator. And last but not least, the universal component socket. It's just your standard breadboard. We do have some convenient power rail connections here, so we don't have to run wires all the way up here. And these are controlled by the switch down here. So it's possible to just flip this to turn your project off and on. And that's it. That's what she is. Really cool. Tons of features on this guy. Almost didn't pick it up. But what I'm going to do real quick is I'm going to wire up a circuit so we can play with this a little bit. As is expected, when you go to do something with old parts that have been sitting around a while or that others have abused, especially in the case of prototyping stuff, there's things that we need to fix. So here we have the readout setup. I removed the backs on them. These actually just slide into a backplane sort of deal. I'll zoom in on that a little later. And it takes power on one side, and there's also 24 volt power on the other side, but it's not really used for much of anything. So, yeah, the 24 volt literally doesn't connect to any of these. So, let's take a look at what's wrong with these guys. I'm not going to go into depth on here. I'm just going to show you real briefly what's going on and where I need to look for problems. So on the readout, the multimeter doesn't work. I can only guess that someone tried to read current when they were reading voltage, and they did that. I don't know if you can see that on the camera there, but that resistor is fried. This corresponds also with the plus 24 volt fuse being blown in this when I first looked at it. So I'm going to have to work on that. Hopefully it only took out that resistor and nothing else. Another problem this guy has is this LED doesn't light up. It looks like there's a couple of transistors here and a few passives in there. So this one should be pretty easy to figure out, and I'll get that fixed. So that's this one. This guy, the signal source, also had a problem. Surprisingly, the pulsar works fine, and the pulsar is just a momentary switch with a 7400 logic gate to invert it for active high, active low, whatever. So that's a pretty basic setup, and the switches are even more basic than that. You can see here that we've got ground here, we've got positive here, and our signal is just soldered straight out to the pin there. So when you flip your switch, you're just selecting between the ground and 5 volt rail. Simple enough. Except only these two switches go to 5 volts. These two, for some reason, are only going to 1.8. Honestly, it's probably just going to involve swapping those switches out. I doubt there's anything really trivial about why those aren't doing what they should. In fact, I might be able to just drip some deoxit into these and flip them a few times and restore them to operation. Speaking of, I'm going to go ahead and remove the backs off of these guys and give them a good clean on the inside so that we can be back and going. I also need to pull apart the function generator. It is not behaving. Surprise, surprise. The slider here is not making any contact. So the only thing this does is change modes based on this switch here. And so I'm going to open this guy up and we're going to give it a good clean too. Fun times when it comes to this vintage electronics. And I kind of figured this would be the case, but yeah. I'll get back to you after I fixed it. That'll teach me to try to do a quick and easy video. Geez. So here we are. This is finally working to a point I can demonstrate a circuit. I had to take all of this apart. This LED wasn't working. It turned out that the LED itself was burned out, which is odd. I was expecting the driver transistor to be blown out or something. Nope, LED was bad. So I went to swap it with something in my stash over here, and I didn't have a matching color. So what I ended up doing was pulling the LED from here to transplant over here so all of these would match, and then putting one from my collection here. So now all of the LEDs over here work, as you can see. This is connected to the reset of a 74191 up-down binary counter. So now that these switches all work, because I was able to clean them up, I was only getting 1.8 volts on a couple of them when I would switch them, so I wasn't able to use them. But if I enable the counter, and see, here we go. This thing's being dumb. Reset it. There we go. Oh, are we being stupid here now? Of course we are. Okay, this still isn't fixed. I've tried to clean it up as well as I can. There's a couple of functions on here that kind of suck. So I can't seem to get this speed function to work at all. Neither can I get the vernier to work, whatever. These functions work, but they're not very linear, so they probably need to be, the linear resistors probably need to replace there. This guy is even more fun, because what I was going to do is feed this binary circuit out to a ladder DAC and show you on here, but this is also crazy unlinear. God. There's some upgrades to be had here. This may be swapped out for a different gauge, and I may build a completely different drive circuit for that. That's not going to happen here, so we'll just look at what we have. So yeah, like I said, you can reset the counter, and then this is the up-down direction on it, so you can see it counting down now. And that's the basic functionality that this is supposed to have, but it is what it is. It's really cool though, and I want to keep working on it. They have these little plastic connectors that hold all of these in that keep wanting to break on me though, so I need to be very careful what I actually pull out. This is probably not coming out ever again, but there's not anything to really break here. The linear pots, I did some deoxide on and they're a lot better. But like I said, this circuit here needs help, and I've got to pull this apart and actually troubleshoot it. At first, the linear adjustment here for the frequency actually did work, but then it stopped for some reason, and now only the switch seems to work. So, yeah, whatever. But that's this guy. Pretty cool, huh? But is it as cool as this guy? This is a Heathkit ET-3400A microcomputer learning system. I picked this up at the same sale I picked this up at, so after working on this guy, I'm kind of worried about getting started on this. But we've got keys here, we've got the LED 7-segment display here. I don't know what they were building on here, but I'll explore that in the future. The ROM is missing out of here, but I believe that this 6809 adapter board that is in here, this is the ROM that replaces this ROM. I do have chips that might be able to flash the original ROM to, but I'm not too sure on that. So I will experiment with that. This video is not about this, and I'm not about to get into cleaning this up and everything, but we've got our LEDs here. We've got buffers, everything. This is a pretty cool system. And the 6800 processor is in a computer that I now have that I'm going to be introducing on the channel soon. I can't wait to get that project started. I'm really excited about that computer, but it's huge, and I kind of need to make a little bit more room in my workshop for it. So we will get to that microcomputer later. But yeah, I just wanted to introduce you to some of these things. They're pretty cool, very neat. I'm excited, like I said, to work with this and this a little bit more, and maybe I'll have some more stuff to show. If I have some cool circuits running on these, maybe they could be neat little games or something to have at VCF. We'll see. If you have any questions, comments, any projects you'd like to see on either of these, let me know in the comments below, and have a wonderful day.